When we collect data, we've learned that we can find central tendencies. We also learned in the last video that we can begin to organize the data into different tables and different plots or different graphs. So what I want to share with you a little bit in this video is what's known as the data distribution types, meaning from a graphical standpoint, what's the data really doing? And so the first thing that we have in your notes is you have what's known as a normal data distribution. And we sometimes refer to this as the bell curve. And let me draw one for you, and you can do it as well. This data distribution shows that there are the same amount of low scores as there are high scores. These scores are the same, and we kind of peak right here. Now, if we think about what a normal distribution does, in a normal distribution, think of if we were taking a quiz. Maybe right here, this is an 8 out of 10. Now, the x-axis represents the scores on a quiz, and maybe the y-axis represents the frequency. So these would be scores of 9, these would be scores of 10. But maybe over here we had a score of 7, and over here we had a score of 6. 10 was the highest, 6 was the lowest, and 8 happened to be the most frequent score. We had the same number of 7s, same number of 9s. The normal distribution, or the bell curve. Now, there's another kind of distribution that we can look at as well. If we go to the right in your notes, it's called uniform. Now, uniform data would look like this. It's basically a horizontal line. And it means that we had the same amount of people score. For example, we had the same number of people scored a 6, same number of people scored a 7, an 8, a 9, and a 10. Uniform. So every score was hit the same number of times. Skewed left data. The graph for skewed left data looks like this. It's kind of got a tail on the left side. It goes up, kind of stays like that. Skewed left data means the data that's farther on the left. Okay? And so let's say we take a quiz and these scores down here are 3s, 4s, 5s, and it just continues to grow. So we had a lot of scores that were like 9s, 8s, 9s, and 10s. We didn't have a lot of low scores, but the low scores that we had are going to skew or move the data to the left, and that's why we call it skewed left. Because all these great scores of 8s, 9s, and 10s, well, if we did a class average or mean, those 3s, 4s, and 5s, because there's just a few of them, are going to drop the overall mean down. Now, the last one is called a skewed right data distribution. This is what it looks like. In this situation, let's say we were taking a quiz, and unfortunately we had a lot of 3s and 4s and 5s. We didn't have that many high scores. So because of this, this is skewed right, which means the tail's on the right. That's a good way to remember this. Now, since we have a few 8s, 9s, and 10s, though, that's going to pull the class average up. That's mainly in that 3, 4, and 5 range. And that's how you can distinguish the two. So now, let's look at the three data distributions shown here in your notes, and let's identify what they are. So the first data distribution that we have is going to be skewed left. I want to do something else with it as well. Skewed left data, I'm going to kind of put a curve on these bars or on this histogram. Now, let's talk about the mean and the median. Now, the median is the middle. And so if we kind of think about where the middle in our data set might be, maybe the middle is kind of sitting right in here. So I'm going to jot that down, the word median. Now, how is that going to compare to the mean? Well, because we've got these low scores here on the end, the mean's going to be lower overall. So in a skewed left data set or data distribution, the median is going to be greater than the mean. Because the mean or average is going to be lower because of these lower scores we have down here. Now, the second one that we have here is a normal distribution. Again, the bell-shaped curve. Now, the median is going to be right down the middle. And because we have an equal number of values to the left and to the right, we can say that the mean is also going to be there. So in a normal data distribution, the median and the mean should be the same. And the last one has a tail to the right. So we say it's skewed right. So if I were to kind of graph what this one is doing here, most of our data is on the left side, but these few items over here on the right are going to pull the mean down. So the median in this case might be like right about there. So let's jot that word down here, the median. And in a skewed right data set, the median is going to be less than the mean because we've got some higher scores that are going to pull the mean up. And so that's how we can look at data distributions from that standpoint. In the last video, you were introduced to a frequency table, and it was a group frequency table. And so I want to close out this concept by talking about a two-way frequency table. And frequency is how many or how often. And so in this situation, we have 100 high school students were asked if they like cats, dogs, or had no preference. Well, instead of making 2 or maybe even 3 different tables, we can make a table, one table that is, that shows all of the data. Now, in the bottom left-hand column, I'm going to put another title. And we're going to call it totals. And I'm going to add a column on the right, and we're also going to call it totals. And what we're going to do is we're going to just do some addition across and down. So let's figure out how many total people preferred cats. Well, there's 8 male and 26 female, so for a total of 34. Dogs was 36 and 22, so that adds up to 58. And then there were 8 that had no preference. Now, how many males were surveyed? Well, it looks like if we add 8, 36, and 2, there were 46. And females, 26, 22, and 8 for a total of 54. Now, how do I know if my work is right? Well, if I add up the 46 and 54 here, and if I were to add the 34, 58, and 8, what number do you think I should get? If you said 100, you're right, because 100 students were surveyed. Now, these totals can be helpful because I can now look at my two-way frequency table and I can go, okay, well, out of anybody surveyed, which animal are they more likely to prefer, cats or dogs? And the answer would be dogs, because 58 out of 100 chose dogs. And you can also see that more females were surveyed in this compared to males. It's pretty close, but it might be skewed a little bit that way. So this concludes this concept. In this concept, you've looked at how to take data we've collected and organize it in different ways, and then begin to make some interpretations as far as what the data is doing.